31, part 2. So if you've watched the first part, then the rest of this lesson goes by pretty quickly. It just goes over the basics of circular motion. So here we have something going in a circular path, and as you can see, the velocity is always tangential to the circle. So if this is going in a clockwise direction, these are vectors that are depicting the velocity. You can say that the object is always accelerating, and the direction of the acceleration, here's a depiction of why the acceleration is towards the center of the circle. At the beginning of the year when we did vectors, we said very rarely will we subtract vectors, but here's a case where subtracting vectors is quite useful because the change in velocity, or the acceleration, is going to equal the final velocity minus the initial velocity. And if we take these two vectors, these ones up here, and we do that operation, we subtract them. In other words, we add the inverse, the opposite. So we change the direction of this, and then we add them. And as we can see, we get a vector. The resultant vector, tail, tail, tip, tip, is going towards the center of the circle. So that's a good depiction of why the acceleration is towards the center of the circle. The next page goes over these terms: centripetal acceleration, and it tells you what centripetal means center seeking, as opposed to centrifugal, which means center fleeing, which we won't talk about in Physics 20. Then it talks about the acceleration and the force. The acceleration is towards the center of the circle, and the centripetal force is also towards the center of the circle. This is important right here. This is important right here. This right here. This centripetal force is not necessarily a force of its own. Rather, it can be thought to be more like a net force, where a force or forces can be the cause of the centripetal force. So again, referring back to the video, the race car going around the track, the cause of that centripetal force was the friction. The moon going around the Earth, the cause of that centripetal force is gravity. And there's an example of when the centripetal force can equal the gravitational force. Then we go over these concepts. Periodic motion. So periodic motion is something that happens on a repeating basis. So for example, the period of Earth's rotation is 24 hours. The period of Earth's revolution is 365 days. So the period is how long does it take to complete one cycle. The opposite, a period is measured in seconds per cycle, which we just usually represent as seconds. The inverse of that, or the reciprocal of that, is frequency. Just back up to this. So T, big T, capital T, is now going to represent period. It is a very specific type of time. It's the time that it takes to go through one revolution. The reciprocal of that is called frequency. So if seconds per cycle is period, then cycles per second is frequency. And the frequency is how many cycles, how many times does it go around in 1 second. And here's the formula on your formula sheet. Period equals 1 over frequency. And therefore, frequency equals 1 over the period. So along with this one, you can rearrange this formula to be frequency equals 1 over the period. And as we said, frequency is measured in cycles per second, which we commonly call hertz, or Hz. So when something is measured in hertz, that's its frequency. Something that goes around 60 times in a second has a frequency of 60 hertz. Example number 1, you are thinking about a new computer. The hard drive of the computer is a metal disk that spins while data is written or read from it. One of the specifications is you need a hard drive that is 7,200 RPM. RPM stands for revolutions per minute. So how many revolutions does it make in 1 minute? How many revolutions does it make in 60 seconds? B, determine its frequency in metric units and explain what this measurement means. There are several ways you can do this. I usually do questions like this as a proportion. So I would say if it does 7,200 revolutions, we're just going to call it cycles in 60 seconds. If we're looking to find the frequency, then we want how many cycles does it do in 1 second. So my proportion here, if it does 7,200 cycles in 60 seconds, how many cycles will it do in 1 second? And then you can just cross multiply and divide, and you end up getting X equals 120 cycles per second, or 120 hertz. All right, and what does that measurement mean? It means it goes around 120 times in 1 second. And then C says determine its period. So the period is how long does it take to do 1 cycle? Well, if it's going around 120 times in 1 second, it doesn't take very long to do 1 cycle. It's always 1 over the frequency. So 1 divided by 120 is, where's my calculator? 0.0083 repeating, so really that's 8.3 times 10 to the negative 3 seconds. That's how long it takes to do 1 cycle. So that should get us through period and frequency. And then here I've just got the formula sheet, and I just wanted to kind of outline what we've done and what we've learned. So if you look at kinematics here, these first 6 formulas were all from the first unit we did, but now we can add these bottom 2 right here. VC, centripetal velocity, or circular velocity if you want to look at it that way, equals 2 pi r over big T, the period, and the formulas for centripetal acceleration, velocity squared over r, and 4 pi squared r over t squared. So 2 new formulas that we know. If you look down at dynamics, we know all these formulas except for this one here, Hooke's law, which we'll go over in the next unit. But we learned all these formulas in the second unit. And then at the end, after we do circular motion, we do energy. Momentum is physics 30. And then all these formulas over here, except for this one right here, are all, oh, here's one more formula that we just learned. Period equals 1 over the frequency. So this formula here in the waves unit also fits in nicely with kinematics and dynamics. On to lesson 32.